Lesson 9.4 is on vectors. Okay, what is a vector? A vector is anything with magnitude and direction. All right, so let's take a look at this vector AB. Okay, how we name a vector is just like we do an array, except on top of it, we only put half the arrow on top, so it's like a little harpoon type thing. Okay, so that represents a vector. There's many models to vectors, but it's something that has magnitude and direction. Okay, magnitude is the distance. Okay, from the initial point, which is the starting point, and the terminal point, which is the ending point. Okay, so for this vector over here, vector AB, this vector starts at A, so the starting point would be A, and the terminal point would be B. Okay? And this has a direction. It's heading, towards that direction, which we'll talk about how to name the direction. Okay? All right, how to name a direction, we're going to have to use a compass. Okay, this is your basic compass rose. Okay? If we're looking down at a map, north is always up, south is always down, east is to the right, west is to the left. And a way to remember this, I'm sure some of you guys know, never eat soggy waffles. And it goes clockwise. Never eat soggy waffles. It helps you remember how the compass rose works. Okay, so here's the first thing we're going to talk about is how to describe a vector. Okay, and we're going to describe it by coordinates. Okay, so here's a graph, and we have a vector OL. Okay, there's our vector, vector OL. All right, and this vector is headed in this direction. If you picture, maybe this is like the port. Okay, and then there's a boat out here. And the boat can communicate back to the port where that boat is at using coordinates. Now the coordinates of a vector, okay, we have to use pointy parentheses, okay, pointy parentheses. Anyway, okay, so how do we get from the port to where the sailboat is at right now? Okay, if we were looking at a graph, we would travel along the x-axis and then we'd travel down the y. Alright, so I know my x-coordinate would be positive, and my y-coordinate is going to be negative, so I know that right away, okay? So let's figure out how to get the x-coordinate. Now what I'm going to do is I'm going to take the triangle that I have in here, and I'm going to pull that triangle out of there. Alright? There's a right angle here. This is 50 degrees. This was the port right here. This is where the boat is at currently. And I know this distance right here, the distance from O to L is 65. Alright? This is my x-coordinate. Now I'm going to use SOHCAHTOA to figure this out. Okay, so here's the angle. Alright, this would be the adjacent leg. And this would be my hypotenuse. AH is ka of our SOHCAHTOA. So it would be cosine of the angle equals adjacent x over hypotenuse 65. When x is up high, we multiply. So the coordinate for x, and we're going to round it to the nearest tenth, would be cosine, I'm sorry, not 65, cosine 50. That's our angle, my fault. Cosine 50. Alright, cosine 50 times 65. Alright, so let me calculate that out. And we get our x-coordinate is 41.78. So that's 41.8. Okay? 41.8. Now we're going to do the y-coordinate. So again, I'm going to take that same triangle that I used before. There's my right angle. This was the port. This is where the boat's at. Okay, now we're going to focus on the y coordinate. And again, this is 65, and this angle was 50. So from the angle, now we have the opposite leg and the hypotenuse, which is so. So now I have sine of 50 equals opposite y over hypotenuse 65. When it's up high, we multiply. So that y coordinate is going to be sine of 50 times 65. If you do that right, you get approximately 49.8. Now I knew this, again, this was a negative value because it's going down. I already put my negative in there, so I could just write 49.8. So if this boat here wanted to communicate back to the port, it could easily just say, hey, I'm at coordinates 41.8, negative 49.8, and they would have a general idea of where that boat is, okay? All right, here's another example. Describe the vector as an ordered pair. Give the coordinates to the nearest tenth. So again, from here, how do I get down to here? Well, again, I'm going to travel along the x and then down on the y. There's my right angle, there's my x, there's my y. Y is negative. You can see all these negatives here, okay? So let's do the x coordinate first, okay? X would be adjacent and hypotenuse right here. That's cosine 59 equals adjacent over hypotenuse. Okay, we're going to multiply those together because x is up high. So we have cosine 59 times 7. All right, we get 3.6. So you can see right away our x coordinate being 3.6 gives us the answer right away. Well, let's make sure we understand how to get the y coordinate. Y is opposite of the angle, the opposite leg. So that's going to be using sine because I'm going to use the opposite in the hypotenuse. So that sine 59 equals y over 7. Again, I'm just going to simply multiply those together. Sine 59 times 7, round to the nearest tenth, gives me 6.0 or just 6. And you can see that is clearly our only choice here is letter B. Okay, next thing we're going to do is we're going to describe a vector's direction. Okay, so we have a vector on this map right here, and you can notice that our graph is now labeled with north, east, south, and west. Okay, so we're going to use compass directions to describe the direction of each vector. Okay, now there's a template for this. Okay, and it's something of something. Okay, something of something. Now let's start with the second one. Okay. The second one is what part of the compass is this vector closest to? This is only 25 degrees away from east, so that means this vector is 25 degrees something of east. Now, it's either north of east, above it, or south of east. In this case, it's clearly below it, so it is south of east. Okay? So it's 25 degrees south of east. Let's try the next one here. Okay, this vector is clearly closest to the north end because the halfway point is 45 degrees, so I know it's closer to the north. So it's definitely of north. So this is 35 degrees. Now, is it east of north or west of north? Well, clearly it's east of north. So that's how you describe a vector's direction. Okay? Here's another example here. Use a compass directions to describe the direction of the vector. Okay? Again, the midway point is 45 degrees, and clearly this is closer to west, so it's of west. 34 degrees, something of west. Now, is it north of west or south of west? Clearly it's below west, so I know it's going to be south of west. So 34 degrees south of west would be choice D. Okay, the last type of example we're going to do is we're going to put it all together. We're going to use the magnitude, which is the distance and direction. We're going to describe our direction using compasses and all that good stuff. So here's an aviation question that says an airplane lands 40 kilometers west and 25 kilometers south from where it took off. So I'm going to draw myself a little map here. Here's north, east, south, and west. We're always going to say that it starts from the origin. Now this airplane lands 40 kilometers west, so it went 40 kilometers west and then 25 kilometers south. So this is 25 kilometers south. 40 to 25. So here's our vector right there. Okay, here's our airplane flying through the air. Okay, don't make fun of my airplane. Okay, the result of the trip can be described by the vector negative 40, negative 25. Negative 40 meaning going left on the x, 40, and going down 25. So this vector down here is described as negative 40, negative 25. Okay, now we're going to use distance for magnitude and direction to describe this vector in a second way. Okay, so there's two steps to this process. All right, first is to find the distance or the magnitude. So let's talk about the magnitude. All right, the magnitude is the length of that vector. Now again, in a right triangle, if I took that right triangle out of there, we know this is 40 and this was 25. We are looking for that length right here. Now when we know 2 out of the 3 sides of a right triangle, we simply have to use Pythagorean theorem to figure out that length. Okay, so it's a squared plus b squared equals c squared. Pretty simple stuff. I'm going to label 25 as my a, 40 as my b. So this is 25 squared plus 40 squared is going to equal c squared. So let me do the math on that. 25 squared plus 40 squared, okay, there's a lot of zeros here. It's a lot. We'll see squared. Now I'm going to square root that to cancel that. So I'm going to square root that answer. And I have my length here, which is 1,000. So it's 1,000, let's see, kilometers. All right, so that's going to be part of my answer, is 1,000 kilometers. Okay, so if I'm going to describe this plane of where it's at from its original place where it took off, first thing I'm going to say is that it's 1,000 kilometers. Now I have to figure out the angle. That's the next step. Okay. Next is my angle. So I can communicate 1,000 kilometers and what angle? Is it something of west? Is it north of east? Is it east of south? We're going to describe the direction as well. So how do we find that angle? All right, let me again take out that right triangle where we have 40 and 25. And then this is our missing angle. Now we talked about how to find missing angles of a right triangle by using inverse functions. Now according to this triangle I have, I'm not going to use my answer. I'm just going to use the 2 given sides. Now if you want to use that hypotenuse, you can, but I'm just going to stick with what they gave me. I know this is the opposite leg and this is the adjacent leg, which is TOA. So it's tangent of that angle equals opposite 25 over adjacent 40. So I'm going to take the inverse tangent of that fraction. Inverse tangent of 25 over 40. And we're going to round our angle to the nearest whole number. So my angle is approximately 32 degrees. Okay? So my final answer, all right, for this problem is bringing it all together. Okay, so this plane is 1,000 kilometers, which again we found by using the Pythagorean theorem, at 32 degrees. And since this is 32 degrees, it is obviously closest to west. And in this case, it is south of west. So it is 32 degrees south of west. right, that's a lot of work. I totally understand that is tons of work, but that's how you find the angle and the direction and the compass directions, and the distance. Okay, so let's try this last one together, and then we'll call it a day. I know this is a pretty long lesson. All right, it says find the magnitude and direction. Again, magnitude is the distance. Okay, direction would be the angle and compass. Okay? So the first thing I'm going to do is I'm going to find this length by using the Pythagorean theorem. Okay, so this length right here would be using a squared plus b squared equals c squared. I'm going to use my a is 4, and my 7 is my b. So this would be 4 squared plus 7 squared equals c squared. If I calculate that all correctly, and I square root at the end here, let's see, 4 squared is 16, plus 7 squared is 49, so I get 65, and I'm going to square root that to cancel that square. So that length here, 65, would be square root of 65 is approximately 8.1, in this case, feet. 8.1 feet. You can see we have 8.1, 8.1. This one's off the table, and 8.1 feet. Okay, so far, we're good to go. We've eliminated C in our choices. Next thing we're going to do here is find that angle. Okay, so I'm going to come down here, and I'm going to redraw that right triangle. All right, this is the angle I'm looking for, and we have 7 and 4 as our two legs. Again, this is the opposite leg, and this is the adjacent leg. That tells you to use tangent of the angle equals opposite 4 over adjacent 7. Okay, to cancel out that tangent, we're going to find the inverse tangent of 4 over 7. To do that right, I'm going to round it to the nearest degree, so I know my angle would be 29.7, which rounds to 30. Okay, so this angle here is 30 degrees. All right, now this 30 degrees, okay, it's closest to east, and it is above east, so it's north of east. So my final answer, if I look here, it looks like B is my correct answer. It's about 8.1 feet, which is what we got using the Pythagorean theorem. 30 degrees, which is what we got using our inverse function here. And north of east is the compass directions. Thank you for waiting this thing out, and I appreciate you listening for the past 18 minutes. I hope you got something out of it, and we'll see you later.